Ioannis Kolaxis, Software Architect and Technology Research Principal Director at Accenture. Ioannis is an inventor, a speaker, and an author of the Green Software book. He has been developing and architecting software applications, mainly in the Java ecosystem, for over 15 years. He invented a novel way of working remotely, having filed 5 patents for software solutions. He aspires to help tackle climate change by empowering every developer to build greener software. Ioannis will be talking about green software, rethinking how to develop software to save our planet. Great. Looking forward for your speech.
Thank you, Martina.
Thank you.
I was here some years ago at the first Open conference, and it's amazing to see how much the conference has grown, and enabling us to hear all the amazing speakers without having to travel abroad. So kudos to you and all the team for setting this up.
Thank you so much.
That is happening also because of you. Because of you, you are here. You are the speakers. So you are elevating this program. You are elevating this conference. So thank you.
You are helping us evolve.
Glad to have you.
Thank you.
The floor is yours.
Good afternoon, everyone. Before we start, I have a question to ask. Think of all the devices you have, like smartphones, laptops, tablets, and smart TVs. How many devices do you have? Raise your hand if you have more than 4 devices. Don't be shy. Yeah, both hands. According to research, each person owns 3.6 devices on average. Of course, this varies by region, ranging from 1.5 devices in the Middle East and Africa to 13.4 devices per person in North America. What we see is that globally, devices grow at a higher rate than the population on Earth. According to the same research, 8 billion people own 30 billion devices. Most of these devices are smartphones. We have around 7 billion smartphones. Next, we have smart TVs, personal computers, and tablets. There is one thing in common among these devices. All these devices run software applications. And here comes our contribution as software engineers. What can we do to reduce the environmental impact of these billions of devices worldwide? But before we answer that question, let's look closely into the carbon footprint of a typical smartphone. This data comes from iPhone 6, one of the best-selling smartphones in history. And as you can see, by the time you buy a smartphone, it has emitted most of the carbon expected throughout its lifetime, with 85% of the carbon emissions coming from production, 3% coming from transport, and only 11% coming from customer use over a period of 3 years. So assume that you change your mobile phone, your smartphone, every year. This will have a tremendous environmental cost. So if we want to do something better for the planet, we must keep our smartphone for 4, 5 years, or even more, therefore spreading the carbon emissions over the years, spreading the carbon emissions over time. This would be a greener choice. Let's think for a moment, why do we buy new devices? Some time ago, I remember buying a new smartphone, and after a while, it stopped receiving new software updates. I was stuck with an old version of the operating system. Whenever I tried to install the latest mobile applications, I would get error messages that these did not support my old operating system. After some time, I gave up, and I was forced to buy a new smartphone, although my old one was working properly. And I had the same experience with other devices, like my smart TV and my tablet. Although the hardware was working correctly, I couldn't run the latest software applications. And that's what we can all do as software engineers if we want to help extend the lifetime of these billions of devices worldwide. We must build software applications that support the oldest versions of operating systems and require minimal compute and memory. One great example of this approach is with Facebook Lite and Instagram Lite. They built these applications mostly for the developing countries where they buy second-hand smartphones, which are quite old. They can be as old as back in 2009. And they still support these devices that have low compute, and they support the Android operating system that was released back in 2009, an Android Gingerbread, which can be quite impressive. So if we want to learn from this experience, what they've done is that they've built thin clients that don't render the user interface, but instead they offload these computations to backend servers in the data centers, and the data center sends via the network compressed images containing the user interface, and the end user devices don't have to do any processing. They just render these compressed images which represent the user interface. Let's take a look at the greater picture of things. We have devices, and these exchange information with the applications running on backend servers in the data centers. And they exchange this information, they interact between them by exchanging data over the data networks. So which of these parts have the highest environmental impact? Can you think? I'll help you with that one and give you a hint that devices, due to their high number, remember we have 30 billion devices worldwide, devices have the highest environmental impact. Can you guess which comes second? Raise your hand if you think that data centers come second. Well, that's not the case. Data networks come second. And the reason is that there has been a shift from fixed-line networks to mobile networks. And every time we send 1 gigabyte of data over wireless mobile networks, we consume much more electricity compared to fixed-line networks. And that's the reason why all these routers, all these switches that form these data networks consume more electricity than data centers. So if we want to prioritize our actions to make some impact, we first need to reduce the size of data sent over the network. The best thing we can do is to compress data before sending it over the network, over the internet. But as engineers, we know that there are always trade-offs to be considered. When compressing data on the sender and decompressing data on the other end, at the receiver, we have an increase in the CPU utilization, which means we consume more electricity. So if we have some kind of data, let's say binary data, and we don't achieve a significant compression ratio, then it may not be worth compressing the data. But that's usually the exception. In most cases, compress your data before sending them over the network. The next thing you can do is to cache data locally in web browsers or proxy servers. So the next time that you need to download a page or use a web application, you don't have to fetch data over the network, but you retrieve this locally. However, again, there is a trade-off of increasing storage whenever we cache these data. And the next important action is to reduce the distance that the data covers over the network by placing the servers closer to our end users. If most of our users are based in Athens, Greece, then we must also deploy our servers here in Athens, Greece. The exception to that rule would be for data sovereignty reasons. So if we have, let's say, a British company, then it is likely that they are forced to deploy their servers in the UK, no matter where their users are based. Next, you can use content delivery networks. So let's assume you have a server in the US hosting some videos. The first time a user wants to play back that video, we retrieve this from the US, and it travels over the network to Greece. and then we cache it in a local server in Athens, also called an edge server, so that the next time a second user wants to watch the same video, we will retrieve this locally from the local server, therefore reducing the distance that the data covers over the network. Again, this is a kind of caching mechanism, so as a trade-off, we must consider that there will be an increase in the storage. And the last thing you can do is that you don't have to move data. Sometimes it's better to process data at their edge. So think of a factory that has thousands of sensors collecting data from production. One approach would be to upload your data to the cloud and process them there, centrally. But you have to move a lot of data over the network. The greenest approach would be to deploy some servers on the factory floor and process all the data locally. Again, there is a trade-off to be considered of the increased cost to purchase and operate these servers on the factory floor. So these are all some trade-offs you can consider when designing green software applications. Going to data centers, there are some things we can do to make them greener. I don't have enough time to explain all the practices to you, but we have two different directions that we usually follow. First of all, we schedule our software applications, especially the compute-intensive ones, to run when the sun shines and the wind blows. That's the time when we have the greenest, the cleanest electricity. Think, for example, of batch jobs. We tend to run these after midnight, but at that time, most electricity comes from coal power plants, therefore having a high carbon intensity, emitting a lot of carbon. On the contrary, if we schedule these jobs to run in the morning, where we have abundant supply of green energy coming from solar panels, then we drastically reduce the carbon footprint of our applications. And then the second direction is to design applications in such a way that we minimize the consumption of computing resources like CPU, memory, storage, and network traffic. Let's take an example which is inspired from all these smartphones, tablets, and laptops that we use in our daily lives. These devices are designed having the energy efficiency of their processors as a key priority so that they extend the battery lifetime. Think, for example, of the latest Apple MacBooks based on the M1 and M2 processors, which are ARM processors. These achieve battery lifetimes up to 18 hours, which can be quite impressive. Could we somehow use the same processors for our backend servers in our data centers? And the answer is yes. We already have ARM processors, AWS Graviton, that's how AWS calls them, and Ampere Altra, which are available by all the other cloud providers, including Microsoft Azure and Google Cloud. And these processors consume up to 60% less power compared to x86 processors of comparable performance. So why doesn't everyone run their applications on ARM processors? Well, you have to port your applications to ARM architecture, which can be quite difficult, especially for legacy applications. So there is a price to pay. However, all the cloud providers offer lower operating costs for this kind of processors. For example, AWS offers 40% better price performance compared to x86 processors, which means that in the long run, you can achieve a return on investment. And for more practices, you can reach out to me. But before applying any practices to make your applications greener, you must first make sure that you measure the carbon emissions of your software applications. Is there anyone here measuring the carbon emissions of their software applications? Please raise your hand. I don't see any hands. So if you don't measure the carbon emissions of your application, you cannot reduce them. And a great way to achieve that is by using an open source tool called the Cloud Carbon Footprint that connects to the hyperscalers, to the cloud providers, collects all the data, all the usage data related to your software applications, and displays the daily carbon emissions for your software. This can be valuable information because for every new feature release or bug fix that you provide, if there is a spike in the carbon emissions, this is a valuable information that you can act on, taking some corrective actions that fix this problem. So there is one thing that you can all do to build greener software applications and help prevent climate change. Whenever we design software applications, we talk about the non-functional requirements, also known as ILITs, like scalability, availability, reliability, maintainability. There are so many ILITs, but we tend to forget sustainability. So please start discussing about sustainability and consider the trade-offs between these ILITs whenever you design new applications. Let's all rethink how we develop software to help prevent climate change. If you're interested to learn more, please do reach out to me. I will be here around, and you can also visit my website to read more information about green software. Thank you.